Factoring quadratic expressions. Factoring is a key point with Algebra 2, so you definitely want to make sure that you have this foundation. It is a long process at first, but the more you practice, the faster you become at factoring. There are 4 steps we're going to go through each time we factor. So the very first thing we're going to look for is a greatest common factor. Then we're going to look and see, can we group in the factoring? And all grouping means is that you need 4 terms. All this will make a lot more sense once we get into the practice problems in a few minutes. After we've checked for a greatest common factor and we've checked grouping, we're then going to check, can we or should we play the game? And then finally, if none of the first 3 work, we have to see, is this quadratic a special case? All right, now let's look at what all this means. So go ahead and copy these 2 problems down. The very first step is we're going to look and see, is there a greatest common factor in each one of the terms? And a term is separated by an addition or a subtraction sign. So 5x to the third is a term, 25x squared is a term, 15x is a term. Now between all these 3, I'm looking to see, can I divide them all by the same number? And if so, what is the biggest, what is the greatest number I can divide each of these by? In this case, it's 5. I'm also going to see, can I take any x's away? And it's got to be the same number of x's. So for this first term, I have 3. The second term, I have 2. And the last term, I have 1. So that means I can take 1x away from each. I can't take 2 x's away, and I can't take 3 x's away. So what I have in red, 5x, that is considered my greatest common factor. And here's how we're going to write our answer. Whatever's on the bottom, that's going to now go outside of parentheses. So 5x and then parentheses. Now we've actually got to do the math. So 5 divided by 5 is 1, which you don't really need since we still have the x's. X to the third, and remember we took one of the x's to the outside. So it leaves me with x squared. I'm going to carry down my plus. 25 divided by 5 is 5. I had 2 x's. I took 1 out. So I have 1 x left. And then minus 15 divided by 5 is 3. I had an x. I took it to the outside. And that's all that's left. So that is factoring by using a greatest common factor. If you feel comfortable, go ahead and pause and try this next one on your own. If not, I'm going to continue to work through it. So I'm going to see what number can I divide all of these terms by. So I can divide them all by 3. And how many x's? What's the biggest number of x's I can take away from each one? So that's 4, this one has 3, this one has 2. So I can take an x squared away from everybody. All right, so again, whatever's on the bottom goes in front of parentheses. 3 divided by 3 is 1, and I don't have to write the 1 because I still have x's. So I started with 4 x's, I took 2 to the outside, I have 2 left inside. Minus 12 divided by 3 is 4. I had 3 x's, I took 2 out, leaves me with 1 x. Now here's where it gets tricky. 3 divided by 3 is 1, x squared, and I took all the x squareds out. Here I actually do need to write the number 1. Because I started with 3 terms, I'm still going to have 3 terms inside. So if you didn't write that 1 on the inside, make sure you write it as a placeholder. Because 3 divided by 3 is 1, and we took all the x squareds to the outside. That is factoring using a greatest common factor. All right, step 2 was grouping. And here you can only group when you have 4 terms. And for each of these examples, we do have 4 terms, but we're still going to check, do we have a greatest common factor between them all? Because we always check step 1. So looking at all of these, can I divide them all by the same number? No. Can I take an x away from everybody? No. So I don't have a greatest common factor. So now I'm on step 2 with grouping. Do I have 4 terms? Yes. So here's how we group. We're going to split the terms in half. And now looking at just these first 2, what is the greatest common factor between these first 2 terms? I can divide them both by 2, and I can take x squared away from both of them. So just like before, GCF goes outside of parentheses, and whatever's left over goes inside. So 2 divided by 2 is 1. Let's see, do I have x's left? I had 3. I took 2 out, so I have 1x left. Minus 6 divided by 2 is 3. X squared, I took them all out. All right, now I'm going to do the same thing for the other 2 terms. I'm going to find my GCF, and you always, always, always have to have a GCF. So here I can divide them both by 3. Can I take x's away from both? No. So again, GCF goes in front of parentheses. 3 divided by 3 is 1, so I really still have that x. Minus 9 divided by 3 is 3. Now, on both sides, what do they have in common? Well, they both have this x minus 3 in parentheses. So that becomes part of my answer. So now, if I take that x minus 3 away from both of them, I'm left with their GCFs. And that's what's going to create the other parenthesis. So I have 2x squared, and then this is a positive 3, so plus 3. And there's my answer. Factoring normally ends up in 2 sets of parentheses. So this is mainly how you're going to be finding your answers, with 2 sets of parentheses. All right, let's try the next problem. So first I have to check, do I have a GCF between all of them? Ooh, in this case I do. I can divide them all by 2. So my GCF goes to the outside. Then I have parentheses. 10 divided by 2 is 5. X to the third minus 10x squared minus x plus 2. So that was my step 1. I was just looking for an overall greatest common factor. Now, inside my blue parentheses, I still have 4 terms. So I'm going to group, which means I'm going to split it in half. So just looking inside the parentheses, what is my greatest common factor between the first 2 terms? I can divide them both by 5, and I can take 2 x's to the outside. So we have 5x squared, parentheses, 5 divided by 5 is 1. I had 3 x's, I took 2 out, so I'm left with an x. Minus 10 divided by 5 is 2. Had 2 x's, I took them to the outside. I'm going to do a GCF for the next 2 now. So I have a negative, and really we have a 1 in front of that x, and then a positive 2. Now I said you always have to take a GCF. So in this case, I really can only divide them by 1. And here's what's really important. Since this first part is negative, my GCF has to be negative. So I'm going to divide them both by negative 1. So negative 1 goes in front. Negative divided by a negative turns to a positive x. 2 divided by negative 1 is a negative 2. And now remember, all of that, the green and the black, they're still inside that first set of blue parentheses with the 2 on the outside. All right, final step. Between the green and the black, what's in common? We have x minus 2 in common. So we're going to pull that out front. So we have x minus 2, and then the GCFs create the second parentheses. So 5x squared minus 1. That's not our final answer in this case because we had that first GCF at the very beginning. Now you don't technically need the blue parentheses. You could just write the number 2 in front, but I kept the parentheses just so you could see. So the second example was an example of using a greatest common factor first and then continuing to group. All right, so we've gone through the greatest common factor, step 1. We moved step 2 with grouping, and now step 3 is playing the game. And this is the most common way you'll see these quadratics written, with 3 terms like this. All right, first, it says a is equal to 1, and a represents the number in front of x squared. So notice in both of these examples, the number in front of x squared is 1 because we don't see a number. So let's go through our steps. Is there a GCF for everybody first? No. Can I group? No, because I don't have 4 terms. So now I get to play the game. So here's what's going to happen. I'm going to take the number that's in front of x squared, so in this case it's a 1, I'm going to multiply it to the last number, which is negative 18. So negative 18. And now I'm going to make a list of everything that multiplies to give me a negative 18. So I can do 1 and negative 18. I can do a negative 1 and a positive 18. I could do 2 and negative 9, or negative 2 and positive 9. Or I could do 3 and negative 6, or negative 3 and positive 6. So these are everything that multiplies to a negative 18. Now what I have to do is I have to go through each of these and figure out when I add them together, which one will equal the middle term. So I'm looking, which one of these will add to a positive 3? So 1 plus negative 18. No, that doesn't give me positive 3. Negative 1 plus 18. No. 2 plus negative 9. No. Negative 2 plus 9. No. 3 plus negative 6. That gives me negative 3, so no. Negative 3 plus 6. That gives me positive 3. So now what's going to happen is I'm going to take both of these numbers and I'm going to substitute them back into the middle. All right, so I'm going to rewrite this now. So I still have my x squared in the front. Now instead of writing plus 3x, I'm going to use my numbers from my list. So I'm going to say minus 3x plus 6x, and then we still have that minus 18 at the end. Now, since we've substituted, we have created 4 terms, which means we can go back to grouping. So if we split this in half, what is the GCF of the first 2? Well, we could divide them by 1, but I'm not going to write 1 because I notice I can also take an x away from both of them. So x goes in front of parentheses, and I'm left with an x on the inside minus 3. And then my GCF of the second 2, remember greatest, I could divide them both by 3, but the bigger number would be 6. So 6 goes in front of parentheses, and I'm left with x minus 3. And I know I'm right because my x minus 3's match. So that gives me one answer. X minus 3 And then we take our GCFs to create the second parenthesis, so x plus 6. And that's factoring. Now again, this is going to be the most common way when we just have 3 terms like this. So I'm going to do another example over here. We have x squared minus 8x plus 12. And remember, there's an imaginary 1 in the front. So first step, we're going to go 1 times 12. Oh, I'm sorry. I forgot to do the very first step. First, we need to see, is there a GCF? In this case, no. We cannot group because there's only 3 terms. So 1 times 12 is a positive 12. So I'm going to come over here, I'm going to make my list. I can go 1 times 12, 2 times 6, 3 times 4, but there are other ones. I could go negative 1 times negative 12, because a negative times a negative gives me a positive, negative 2 and negative 6, negative 3 and negative 4. Now I'm looking from my list of numbers which one will add together for a negative 8. So 1 plus 12, no. 2 plus 6, that gives me positive 8. 3 plus 4, that's 7. Negative 1 plus negative 12, no. Negative 2 and negative 6. So we're going to substitute those back into just the middle. So I still have x squared, and now instead of writing minus 8x, I'm going to say minus 2x, minus 6x, and then plus 12. Now I have my 4 terms, so I can split the middle, and I'm going to group. So my GCF of the first 2 is x. X goes in front of parentheses, and I'm left with x minus 2. GCF of the second set, the second half, remember, whenever I start with a negative, I know my GCF has to be a negative. Now what's the biggest number I can divide these by? I can divide them both by 2, I can divide them by 3, but 6 is going to be your biggest number. So negative 6 goes in front of my parentheses, and I'm left with x minus 2. And I know I'm doing right because x minus 2's match up. And that creates one answer. So I have x minus 2 in parentheses, and then I have my GCFs of x minus 6 as my other answer. And there's your answer to factoring, playing the game. Now we got 2 more examples, and this time, notice we actually have a number in front of the x squared. So this is when that a is bigger than 1. All right, first we look, is there a GCF? So in my first example, no GCF. We can't group. So just like we did previously, we're going to take the number in front, multiply it to the number at the end. So 6 times negative 5, that gives me negative 30. Now I'm going to make my list. So I can do negative 1 and positive 30. I could do negative 2, positive 15. I could do negative 3, positive 10. I could do negative 5 and positive 6. And then I can do the opposite. So I could do a 1, negative 30, 2, negative 15, 3, negative 10, and 5, negative 6. Now you don't have to make this list every single time, and in fact I'm going to not do it as much as we get going, but I want you all to be able to see where I'm getting the middle numbers from. So from this list, I'm looking what adds to a negative 7. Let's see, which one adds to a -7? -3, ooh, -3 and 10, that gives me +7. But 3 and -10, that gives me a -7. So just like before, I'm going to substitute them back into the middle. So the only thing that's changing is the middle. So in the front, I still have 6x squared. Now I'm going to have plus 3x minus 10x, and then minus 5 at the end. And it doesn't matter the order of the green numbers. You could do minus 10x plus 3x as well. All right, now I have my 4 terms, so I'm going to group. And then GCF of the first two, I can divide them both by 3, and I can take an x out. So 3x goes in front, and then 6 divided by 3 is 2. I still have an x, plus 3 divided by 3 is 1, and I do need the 1 because I don't have anything left. I need that placeholder. All right, GCF of the second half. Now, because the first number is a negative, we know our GCF is negative, and in this case we can divide them both by a -5. So -5 goes in the front. And I can do -10 divided by -5 gives me a +2. Still have the x. -5 divided by -5 plus 1. I know I'm right because I have my parentheses matching up. So there's one answer, 2x plus 1. And then the GCFs create the second answer of 3x minus 5. And there's my answer. All right, if you want to try the last one on your own, go ahead and pause the video and then check back in. If you still need to watch, that's fine. I'm going to go through this, but I am going to pick up the speed a little bit. So first step, looking for a GCF. I don't have any GCF for that one, and I can't group because there's only 3 terms. So I'm going to take the first number 3 times the last number 4. That gives me 12. And then I'm going to make my list for +12. I can do 1 and 12, I can do 2 and 6, I can do 3 and 4, or remember I can also do the negatives of each. -1, -12, -2, -6, -3, -4. And I'm looking for which one adds to a -13. And out of my list, I have my -1 and my -12. So that's getting substituted back in the middle. So 3x squared is still first. My middle becomes -1x minus 12x. And then the end is plus 4. So again, the only thing that changes is the middle. All right, now I'm going to split because I have my grouping. GCF of my first 2 is x. So x goes in front of parentheses. And I'm left with 3x minus 1. GCF of the second 2. First number is a negative, so my GCF will be negative, and it's going to be -4 in this case. So -4 goes in the front, and I'm left with 3x and then -1. Negative divided by a negative is a positive, and then 4 divided by -4 is -1. I also know I'm right because my parentheses match up. So then we have 3x minus 1 and x minus 4. And there's our answer. All right, next class we're going to talk about the special cases, because remember there's that 4th step, and that's dealing with difference of squares and sum and difference of cubes. But mainly, overall, the first 3 steps are the main things that we're going to be focusing on with factoring, and please continue to practice them because the more you practice, the better you're going to get at it. As always, reach out to me if you have any questions.